Last time we met, I gave you an introduction to serializing and the framework I built for it. And I made some significant changes to it over the last 6 days or so. So I just wanted to briefly go over them. So first major change was that the unpacking transforms were pretty lousy. You are given an input where to read from on an unpacked transform, and also the second parameter was just a pointer to storage. That storage was allocated inside. Is it? Storage was allocated inside unpack or unpack type here. Was created on a stack. Then the object was created inside this storage. That it was moved out of this function. And then I had to have this on exit trickery here, which would take a reference to this storage, cast whatever those bytes are, cast them into type T, and then call a destructor on it. So it worked, but it wasn't pretty. And the user had to write transforms that were counterintuitive somewhat. You had to do placement new into that buffer. And actually, there was a possibility of undefined behavior because I was doing placement new into this buffer. And assuming that the placement new happened in that exact region of memory, which I've been told by Redditors, that may or may not be true necessarily. And I really should have examined the return value of placement new, which I was not doing. So the major change to it that I made, thanks to kind readers on Reddit C++ forum, was to change this unpacking transform such that all you need to do is just return. So that is way more intuitive, right? You just write a transform, it does something, and then it simply just returns the value, right? And whatever the type it returns is automatically deduced here, it's lambda, and then the rest of the framework picks it up. You can see here again for strings. So you unpack the length, and then you simply just return a string. Now, second change I made was because the buffers, the serialized buffer is a std vector of std byte. Std byte is a strongly typed enum, which uses unsigned char as its underlying storage. There was no way to implicitly convert the values of std byte to, for example, char, which would have been nice, because I could have more easily just unpacked those bytes and create a std string out of it. So instead, I created something called Bytecast buffer input key, long name, mumbo jumbo. But what it means is that it is a type of an iterator. It's a random access iterator on type T. It can be any type as long as the size of that type is the same as size of buffer input value type. I could have just set std byte here, but let's use the aliases we create. And you can use this bytecast buffer input type to do a cast from std byte to any other byte representing type. In this case, I needed to cast from std byte to char. So it just takes a reference to the buffer input iterator, and then the core of it is here in the dereferencing operator. It just returns a const t reference, so a reference to a constant t, by dereferencing the buffer input iterator that returns a byte, and then doing a hard cast, reinterpret cast in this case, to a const reference to a t. And as long as this is, I'm not honestly sure if this static assert here makes sense or not. Maybe it's okay to cast a byte to say an int or short, but I had a hunch that it may be needed here, so I kept it. And then I had to add a few operators to make it somewhat complete, so that it played nice with the strings constructor and how deep the strings constructor goes, and that ends up calling STL functions like advanced iterator or find a distance between two iterators. So it needed the plus plus prefix and postfix increments. To do this, it needed a minus operator. What that is you take an iterator minus an iterator, and it gives you a distance between them, right? So how many times would you have to call plus plus on the first one to get to the second one? That returns std : ptr diff underscore t, pointer difference type, but I'm a big fan of using oro whenever I can, so I just do it this way, except bool. For some reason I had to explicitly. And they also needed an equals equals and not equals operators. So that simply delegates to the reference that it is holding. And calling it plus plus prefix postfix on it just forwards it to the reference input iterator it has, so, and advances that iterator. So it looks like it advanced itself, but it's really advancing its underlying iterator it's using. Second thing, I changed slightly the onExit object. It's type of a RAII, I suppose you could say. I needed it to do something after a function return, or after return statement of the function. Right? Otherwise, there is no way to do it other than through stack unwinding. And so I improved it slightly, where you can tell it to, by default, it will do what you tell it to do, but you can also say don't if you change your mind for some reason. And there may be good reasons to do that, usually in the presence of exceptions. You may want to cancel that ability. But in this case, you would normally initialize it with do it equal to false, and only if some statement that could potentially throw an exception succeeded, then you would call do it. And again, that was needed when I was unpacking. Let's see, where was this? When I was unpacking a type here, right? It was placement nude into that storage, but that could have thrown an exception. So I needed an ability to disable calling of the destructor, but it's no longer here because it has been rewritten, reworked in a major way. So, but I kept it there. It may be useful for something. I still need it in a couple other places where I'm unpacking bytes or unpacking a value, and I do that. Unpacking a value, I do that by just casting from a pointer to that value type, and unpacking bytes performs a copy of n bytes into some output here into this output pointer, but copy n takes the iterator by value, not by reference, so it doesn't advance this iterator that it gets here. So I had walk it. I said, hey, on exit, just advance this iterator by the same number of bytes. Now it is possible, I suppose, that I could wrap this iterator into a reference wrapper. So let's see if that would work. Just out of curiosity, reference wrapper is a simple object that acts like a value. You can copy it, but internally just keeps holding a reference to something. So when you have a case like this where a function takes a value, something by value, but you really, really want it to take it by reference, because whatever the function does with the copy of the value, you actually want to reflect it afterwards. So std ref on any given type would return a reference underscore wrapper, I believe is the type. And this may just work in this case, but I'm not sure if it can actually use this wrapper reference. Yeah, it can't. Because I copy n is expecting an actual iterator, and this reference wrapper may not play too well with iterator semantics. Okay, never mind. That was supposed to try. And similarly, when unpacking a value, because I just perform a cast from the buffer input, and this unpacked value returns whatever those bytes represent. After I return this reference, I want to advance this iterator as well. So that's another change. And finally, I think the most significant is that this framework started as a proof of concept, if you would, and it was just a set of global functions, which wasn't very clean, but it worked. but there's no way to create multiple instances of the serializer. So I decided to finally wrap it inside a class. And on that class, you create an instance. You can add pack transforms, unpack transforms, pack size transforms to that class. And that also changes the signature of all these transforms, because now they take an additional parameter, which is a const reference to this serializer. So every time the serializer calls a transform function, it will pass itself as the first argument, like this. For example, pack type, transform, passes itself, followed by the extra arguments. And this is needed because now that all these functions became member functions of the serializer, when creating an unpack transform, you need a reference to the serializer, right? So it will always pass itself, and then you can call s.unpack type. So you know your transform that you associated with this particular instance of a serializer will pass a reference to this particular instance of a serializer for you. So perhaps slight additional complexity, but I think absolutely worth it, since now we can create instances. I could have serializer 1, serializer 2. Another thing you'll notice that I did not define a single special member function for this class. So whatever the compiler thinks is to be there. Copy constructor, move constructor, move or assignment operator, whatever destructor, default. Default. There's no. It's always default. I meant to say constructor. And I did that because the only members that this serializer class really has are those maps. So map of packing transforms, unpacking transforms, and pack size procedures, which they just map the hash of a type to a particular lambda function like this. When you're adding a transform, it will get a hash code out of a type ID, which returns type info, and that can give you a hash code, and then you can associate it something in an associative container with a particular type. But you're doing it by getting a hash code of that type. You couldn't just say, right? You couldn't just say T here. That wouldn't work, because that is a type. That's not a value. But this type ID allows you to sort of treat types as if they were values. All right, so these are the changes that I wanted to briefly go over. The example program has also been updated, and all of this I pushed to my GitHub. So if you want to look at this code, if you go to my GitHub page, it will all be there for you under the project blog and source.